Hello everyone, welcome to the fourth video of A-Level Computer Science. In this video, we're going to talk about internal coding of text. So in the last video, we already talked about internal coding of numbers. But what about the internal coding of text? How do texts on our mobile phones are stored and displayed on the screen? So the people, in order to display English languages, the ASCII code was first being developed by the American. And ASCII code stands for American Standard Code for Information Interchange. And it has the longest time and the longest history, which is the first code to display a text. It used 7-bit to display a number or a text. So for example, the number 0 is stored as 00110000, and the number A is stored as 01000001. You may have a question bear in mind, why here we have 8-bit, but here we say it's the 7-bit version of the code. It's because for ASCII code, the first binary number is always 0. We will learn more about why of it in the next couple of slides. So taking A as an example, we can see the A is starting with 0, then 1000001. So it's a 7-bit code. So how many different codes available for ASCII? Well, on the previous slide, we said it is a 7-bit code. So 2 to the power of 7 is 128. So for the ASCII code, it has 128 unique characters available, which means that it has 128 different codes. Okay. Is there any interesting properties for the ASCII code? Well, the answer is definitely yes. The first property, let's have a look at these numbers first. So character 0, character 1, character 2, we saw these are the binary representations. And character A, character B, character C, so these are the binary representations. And the small letters, A, B, C, are in here. So we can see the codes for numbers and for letters are in sequence, so that, for example, if 1 added to the code for 7, the code for 8 is produced. So for example, here we have code 0, and this is shown here. So if we plus 1 to it, we have code 1. And if we plus it again, we have code 2, which means that it's in the same sequence as what we've done in representation of numbers directly. So this is really a convenient feature of why we're using the ASCII code. We were going to show an example later in Python about how we can generate number 1 if we know the number 0. And the second case is that the code for upper letters differs from the code for the corresponding lower letters only in the value of bit 5. So if we see these as an example, for example, A and smaller a, it's only different in this bit 5. So bit 0, bit 1, bit 2, bit 3, bit 4, bit 5. Remember that the right-hand side bit starts from bit 0. So for the smaller letter and the capital letter, it only differs in the bit 5. However, there is lots of problems with ASCII. The first one is too few languages supported. For example, my home language, Chinese, Mandarin, is not supported with ASCII. So if we force it to display, it will display some random message like the one shown in the right-hand side. So in order to solve this problem, we invent Unicode. It's not Uniqlo, but it's Unicode. For example, when we save a text file, we can choose to use Unicode, which is now the latest version 8 of Unicode is UTF-8. So for the Unicode, the aim of the Unicode is to be able to represent any possible text in code form. In particular, this includes all languages in the world. What a great desire it is! The most popular version of Unicode, which is discussed here, is named UTF-8. The inclusion of 8 in the name indicates that this version of the standard includes a code defined by 1 byte, in addition of codes using 2, 3, and 4 bytes. We will see how in a second. Well, the difference between the ASCII and the Unicode, well, the ASCII only supports 128 characters, while the Unicode supports much more characters, which we have seen before, most languages in the world. So ASCII supports limited languages, Unicode supports more languages. The second point is Unicode requires more space than ASCII. Well, as a Unicode, it uses more bytes to represent a word. It can represent more characters. So it makes sense that it requires more storage space than ASCII. And the third one is Unicode uses 8, 16, and 32-bit characters based on different presentation, while ASCII is 7-bit encoding formula. So we said before, ASCII is a 7-bit code, while the Unicode uses more characters. And here explains how Unicode could display different characters while still compatible with ASCII. It's optional. If you're interested, you can read the right-hand side. I'll briefly say that if it starts with 0, then the thing is exactly the same. The Unicode is exactly the same as what we talked before, the ASCII code. But if instead it starts with 1, then the thing is a bit different. You can read the right-hand side for more information. How can we feel the character codes? Well, normally we can't see what the code really. We can see them in the Python programming. Well, I'm going to do a brief introduction here. We're going to learn more about it when we are learning the part 2 of the A-level computer science about the AS programming. So here I'm just doing a brief introduction. So the first function, odd, will convert a character into its Unicode value and in binary. So remember 2 points, Unicode and in binary. As we learned previously, the Unicode, if it's for a simple English letter, it is exactly the same format as ASCII. So for example, the lower letter A, what will be its binary value, which means that this function output. So have a try with this number to see what its binary value is. Okay, if you need longer time than this, just pause this video and I'm going to have a try in my Python interpreter. So let's have a try together. So search for IDLE and then we go, wait a second. And then we go odd A, which should have a number of 97. Okay, did you get this one correct? Hopefully. Let's moving on. The char returns a character that represents a specified Unicode. So for example, we see char 98, it will return B. So it's like an inverse function of the previous one, odd. So when we say odd, we convert a character to its Unicode. When we say char, we do the reverse thing. So we convert the Unicode back to the char. So let's have a try. So char 98, it will be B. Okay, after knowing this, there is something interesting that we can do with ASCII code and Unicode, which is here. Interesting question. What will this output be about of the code odd A plus 1 of char? Think about it. I will give you a little bit of hint because I mentioned before that the ASCII code are in sequence, which means that if you add 1 to the corresponding code of A, you get B, and if you add 1 to corresponding code of B, you get C, and so on. So let's first have a try in Python to verify your sort to see if it worked correctly. So character odd A plus 1. So so we got B here. Why? Because first of all, the odd A, which we return 97, then we plus 1, we got 98, which is number B. So just do a little bit of extension. What will happen if I change